Hello guys, let's solve this problem. Question 1 says this question is a projectile, vertical projection or vertical motion. Rather, they said a ball is thrown vertically upward with a speed of what? 35 meters per second. Let's assume this is the ground and it returns to the ground. So that means thrown vertically upward, 35 meters per second. And it returns to the ground. Okay, it's returning. But what they now tell us to do is that, say, what is the time it takes to get to the point, is a point 5 meters above the ground as it returns. If the maximum height reach is what? 62.5. I mean, from the ground, the maximum height is what? 62.5 meter. So in this case now, what I want to do is that let me assume that to the ground, this is the ground, it is 5 meters above the ground now. Now, if you assume that that is 5 meters above the ground, what we're going to do now is, let's assume it is returned to this point now. It was thrown from the ground level. Let's look at the ball and it returned to this point. Now they say find the word velocity at this point. Now what I want to do is that our H initial, let me change my marker. Our H initial is equal to, what is our H initial here? 0 meter. It was thrown from the ground. Now, as it's returning back, they say we should calculate what? The velocity at 5 meters above the ground. So that means our H final is equal to, what is final what? Height. It will now be what? 5 meters. Now, since we know this as 5 meters, now we are calculating the velocity at that point. So we are going to use H1 as our 5 meters. And using the formula, we are looking for the time from A to B. You understand? They say what is the time it takes to get to 5 meters above the ground? So this 5 meters above the ground. So we are going to use H1 minus H0 equal to UT minus half GT squared. That's the formula we are going to use. Why? Because it has the time we are looking for. They say take G to be equal to what? Let's take our G to be 9.8 meters per second square. So we can use this formula to solve our problem. Now, this is the displacement X. So we're going to have what? H final is 5 minus H initial equal to what? 35 times T minus half what? GT. G is what? 9.8 T squared. So what do we do now? This will give us what? 5 equals to what? 35T minus what? Then this will give us 4.9 T squared. 4.9 T squared. Now, what I want to do now is to collect like them. Let's turn it to quadratic equation rather. 4.9 T squared minus, if this one come here become minus, this one come here become plus, 35T plus 5 equal to 0. So how do we find our T now? We use what they call what? Quadratic what? Formula method, or probably you can use your calculator. So if you use our calculator to solve it, to solve for time taking there, we are going to have what at what? Let's say we use our A is 4.9, B is minus 35, and C is 5. So our answer is what? 6.997. Then we are going to have seconds. Then another T2 is what? 0.1450 seconds. Now this T1. Now since the question, these are the two times. Now since the second, the time is what? The first one is there, 0.146, and the second one is also there. Look at the option D. So what I will say is that because now T1 is too small, or let me say T2 is too small in magnitude. Therefore, my time is equal to what? 6.997 seconds. Option what? That's option D. Now that is number one for us. So I hope you understand everything. So because the initial height, don't forget, is here. The final height will not be height where the body landed. What is the height? Above the ground where the body landed. So that is h equal to what? Fine, because we assume that they are calculating the what? The time it takes to get from A to what? To B, which is 5 meters above the ground. Now this is question 1. Now let's look at question 2. Let's look at question 2. Question 2 says that what? A particle of mass 0.5 is released from the top of this is a free kind of under towards gravity. Is released from the top of a building. Now the velocity of the mass is what? 10 meters per second is released from top of a building. So let's assume this is our what? The building is released from here. From a building, then now see what? The velocity of the mass is 10 meters per second after traveling 1/3 the height. That is to say, let's say the height of the building is h. Let's call the height of the building h. Now, after it has traveled what? 1/3 of the what? Of the height of the building. From here to this place, what? h/3 from here. h/3 from that point. After it has traveled what? 1/3 the height of the building. With what velocity will the particle hit the ground? Now, we need to calculate, that means after it has traveled 1/3, the velocity is 6. Now, at this point, now we can say u equal to 0 at that point. We are going to assume that the body stop here. This is the height. Let's take this as our height. Just like when you throw a body downward, the height at the ground level is 0. Now we are going to assume that this is our ground level so that we can use this height to solve. Just like when you are throwing a body downward, you will know that what? At the ground level, u equal to 0. So in that case, we are going to take this one as our ground level and assuming it's falling, it has fallen the height of what? h/3. So we are going to use v squared equal to u squared minus 2g what? h. Why are we using this formula? Number one, this formula we adjusted to plus because it's now moving towards what? Gravity, where g will be positive. Number two, we are using h as our what? h/3. And that is what we are going to use as our h. Then the final velocity, the velocity is coming with. Is coming with the velocity of this, and that is velocity we will call that we will use as final velocity, which is velocity at this point. So that is what? 10 squared equal to 0 squared plus what? Plus because it's coming towards gravity. 2 times what? 9.8. They say we should use 9.8 as our g, h/3. Now we can get our h. It is very easy to work because we are looking at velocity at which you hit the ground here. So now what do? We would have 100 equal to what? 0, that will cancel. 19.6 h/3. So what do we have now? I would have what? 300 is equal to what? 19.6 h. Therefore h equal to what? 300 over 19.6. So if you press your calculator now, what do you have? h/3. Then we would have what? 300 divided by 19.6. That one would have 15.3. So h should have 15.306 meter. That is the full height now. So our h, the full height now, is equal to what? 15.3 meter. That is full height now. Now to get the velocity of impact, v will not be equal to what? This one will not be, u will not be 0 here. Just like we make u equal to 0 here, we assume this is the full height. And our velocity was what? Velocity, final velocity. So we want to make our u equal to 0 here, which is what? At the ground. This is the real ground, the ground level. So this is the height. So I want to use v square again equal to what? What is our v square now? Our v square will not be what we are looking for. then u square plus what? 2gh. Now, what is our u? 0 square plus what? What is our g? 2 times 9.8 times what? What's our new? This is 15.3. So 15.3. So v will now be square root of what? 2 times 9.8 times 15.3. So what will now be our answer? So 2 times 9.8 times what? 15.3. 15.3. That is 299.88. The square root of the what? Of 299.8 will give us 17. Square root of everything will give us 17.3 what? 32. Let me put it down seconds, or meter per second rather. Because this is velocity. So this is the velocity at which you hit the ground is what? 17.32 meter per second. Now the last one, which is number 3 for this section. So our answer for that one now is A for number 2. Now for number 3 question, which is the last one. They said a stone is thrown vertically upward with a speed of 20 meters per second from the top of a building at 35 meters high. Full stop. 35 is thrown from what? Let's say this is the what? The height. This is the height of the building. This is 35 meters high. Okay. It's thrown from the building with a speed of what? 20 meters per second from the top of the building. So it's thrown upward now with a speed of what? 20 meters per second. What will be the speed of the stone when it reaches a point 15 meters above the ground? So it will now go and return. So it's 15 meters now above the ground. So what we are now going to do now? Our H initial is what? 35 meters. H final is what? 15 meters where the body landed. So, or the stone landed. It was thrown from here and landed here. So A to B. Now, the initial velocity is what? 20 meters per second. G is equal to what? 9.8 meters per second square. What again we need? Then we have our what? Formula to use. We are looking for what? Velocity at this point, which is V. So we are, for us to use for V, the suitable formula is what? E square equal to U square minus. Why is it minus? It is moving against gravity here. So in that case, minus 2G what? The displacement from here to this place is what? H1 minus what? H0. So if that is what? Our displacement, what we're going to do is to simply what? Our V is what? V square equal to what? Yeah, what we are looking for? 20 square minus 2 times 9.8. Because they say we should use 9. Okay, they say we should use 10. Sorry. The last question say we should use 10. Follow instruction, please. Please. 10. So H1 is what? 15 minus what? H initial height, initial position is 35. So I would have what? 400 minus 20 times what? Minus 20. What do you have? Plus what? That is 800. So V square equal to 100. What is our V now? Square root of what? 800 will give us what? That is 28.3. 28.3 approximately. 28.3 meter per second. So that should be what? Option what? A. So our velocity of what? Impact at B is 28.3 meter per second approximately. That is question number 3. See you in my next video. Thank you.